also by satellite data. And the satellite data gives the possibility of a more global coverage of these observations. And also there is the question of paleoclimatic instructions, which is very important to understand the climate system and also to project the future climate. So this is two statements taken from the IPCC Fifth Assessment Report, the Working Group 1 report, and perhaps it's interesting to read the lower sentence: working on the climate system is unequivocal, and since the 1950s many of the observed changes are unprecedented over decades to millennia. The atmosphere of Russia has warmed, the amounts of snow and ice have diminished, the sea level has risen, and the concentration of greenhouse gases have increased. This is documented in many figures. That report, that, by the way, is available online in the internet. Now, as regards satellite observations, we have observations concerning the land. These are in situ, the network of meteorological stations that are certified by the United Nations Geological Organization, Geology Organization, then the ocean, the waters, and then the geostationary satellites on the left and the low Earth orbits on the right. So these information can complement each other, and is this complementarity that is very important to improve and promote in the future. So one other aspect is that we need to understand better the climate system that is composed of not only the atmosphere and the ocean, but also of the cryosphere, part that is all the ice, mountains and at the poles, but also the biosphere and the lithosphere. So it's a complex system, and in order to understand climate change, we need to have a better knowledge of this climate system. Now, the point that is made in this presentation is that by using both observational and model information, so combining the two, plus the errors involved in both these methodologies, and this is called data assimilation, and it's a very important procedure that improves our knowledge. And you see on the right, as regards the ozone depletion in the Antarctic, that on the left you have the observation, on the right you have a model, but then if you combine the data and the model, then you get ozone analysis, which improves on the model. So this is a very important aspect, data assimilation using satellite data and using in situ observations. Now, what is happening? The Global Climate Observing System defining and regular updating of climate requirements for global observing systems. So it is a question of design, it's a question of having continuity, operational suite of satellites, weather forecasting plus climate, and then the opportunity, the research satellites that have been involved in this effort from ESA, NASA, and JAXA, and so on, and then the ground-based measurements and also everything that has to do with the climate of the past, the paleo records. And again, the emphasis on the complementarity between ground-based networks, monitoring and evaluation, and the added value that this complementarity offers. So why we need climate observations? Well, I think this has been illustrated already: detect further climate change and determine its causes, model and predict the climate system, assess impact of climate variability and change, monitor the effectiveness of policies for mitigating climate change, support adaptation to climate change, develop climate information services is a very important thing for the future. I mean, one needs information to adapt to climate change, and this can be provided by climate information services. Promote sustainable national economic development and meet the requirements, other requirements of the United Nations Framework Convention on Climate Change, the UNFSCC. Benefits from climate change observation analysis, decision and policy making for benefit of society, and this impacts on many fields like agriculture and soil management, biological diversity, biodiversity, and ecosystem management, coastal and marine protection. This coastal is a very important aspect. It was referred yesterday. The number of people that live in coasts is very large, and then it's going to increase in the future, and coasts are vulnerable because of more severe weather, so extreme events of weather, and also because of sea level rise, but also energy, financial services, fisheries, forestry, human health, I mean heat waves, and also vector-borne diseases, and infrastructure, tourism, watershed, and so on. Collaboration, what is needed? Collaboration between all stakeholders, research, operational agencies, policymakers, and in designing the global climate observing system, the GCOS, and funding for implementation. And this is kind of a circular process, a process that involves what needs to be measured, how to do it, and then by whom and by which functions, and then assessing and then starting this process again. So it's kind of a circular process. And here you have, again, this circular process, the future. The global climate observing system improves observation capabilities by identifying, promoting the actions in its implementation plans, operating and cooperation mechanisms, developing regional action plans, and advocating improved national coordination. GCOS regularly evaluates and reports on the process that has been made on implementation activities. Thank you for your attention on this presentation. I mean, questions that you may wish to pose and comments, I mean, they will be addressed to Dr. William Lahoz. So now we proceed with the presentation by Mr. Chu Ishida, who is Senior Chief Officer of International Affairs for Space Applications at JAXA, and he is also at CREO's Secretariat, and his background is an engineer on space sciences, and particular satellites. You have the floor.
Okay, thank you very much, Mr. Chairman, and the distinguished audience, and ladies and gentlemen. It's a great pleasure to be here to present JAXA's, contribution to climate change monitoring. And since I found the article just yesterday that President Obama just announced his, a great, decision to slash the CO2 emission by 30% by 2030. So I'd like to start with this, slide. President Obama visited Tokyo last month, and at that time that we showed a GS map, global precipitation map, which was shown on this GeoCosmos spatial display with a high-resolution LED display on the spheres of the Earth. And then he asked how often the data was gathered and how often updated, and he commented it's very impressive. And actually, this is a group GS map. This is the data updated hourly, and then this is produced after 4 hours of the data collection by integrating more than 10 satellite from the geostationary to low Earth orbiting satellite. I show this because I found at the last night dinner, my colleague does not know this. Even President Obama knows this, so he should know this magnificent data set which we are producing. And GSMAP is produced by this GPM constellation, and we launched GPM core satellite on February 28th from the Tanegashima. And GPM is a US-Japan collaborative corporations, and we developed a dual frequency precipitation radar which observes the precipitation in a three-dimensional way. And then you can see the left bottom image of the first image from this satellite. And the DPR produce the most highly accurate data for the precipitation on orbit. Therefore, this DPR provide the standards for these precipitation constellations. And this shows the rainfall climatology data produced by TRM, the former satellite before the GPM, for 14 years data accumulations. And this is a first kind of data set produced by these missions. And then this is a very significant data set because before this, there was no accurate data set over oceans. And we are very lucky since the TRMM design life was only 3 years, but still the TRMM operating and collecting data more than 40 years, and now being succeeded by a GPM satellite. And we are going to continue these observations. And one of the GPM constellation is the Shizuku. In Japanese, it means droplet. And then Shizuku is one of the global change observation missions, GCOM. GCOM is JAXA's flagship mission for climate observations. GCOM W stands for water, and then GCOM C is the C stands for climate. And GCOM W1 was launched in May 2012, and the GCOM C1 is now being developed for target launch in 2017. And it is our original plan to continue the development, these two series of satellites for 3 generations. But after GCOM C1, it is not clear whether we can continue to develop the second generation satellites. And this shows the AMSA-2 on the GCOM W, Advanced Macro Scanning Radiometer on GCOM W1, which was shown in February this year. And then Advanced Macro Scanning Radiometer has a low frequency spectral bands, and which can penetrate through the cloud and then provide the sea surface temperature night and day, and under all the weather conditions. And it's probably a very good SST data set. And you can see the bottom, this is an anomaly of the ENSO. And then you can see that El Nino is now occurring. And then this bottom data set for more than 12 years being produced by integrating AMSA-E on Aqua and also WINSAT, and also AMSA-2 on GCOM W1. So we need a continuation of the missions. When there are different missions, then we have to make sure that the data are on cross-calibrated and then make good continuations. And another contribution that JAXA is making is a GOSAT, a greenhouse gas observing satellite. And this was launched in 2009. And this is our world's first dedicated mission to observe global greenhouse gas, CO2, and also methane. And one of the features of this satellite is that this employs the Fourier transform spectrometer which is different from the grating spectrometer. And then JAXA has been developing Fourier transform spectrometer technology, which provide a higher spectral resolution and also very wide spectral range. Therefore, we can use both the near-infrared and also thermal infrared data in order to estimate the CO2 and the methane. And this is a daily mean CO2 concentration produced by GOSAT being integrated with the in-situ data. From this daily variation of the data, we can see how dynamically CO2 is changing. And we could find that Siberia sink more than expected. And also, we can see the high CO2 concentration over mega cities and also wildfires. And lastly, I'd like to introduce the ASCIA, which we are now developing in cooperation with Europe. And this is a Earth Cloud Aerosol Radiation Explorer missions. So we are going to measure the Earth cloud and the aerosol. And JAXA is developing a CPR cloud profile radars. And the JAXA has been developing PR of the TRM and the DPR of the GPM and then a CPR of the ASCIA. This is a series of the rain radar and then a cloud radar development. So we'd like to continue the development of this radar technology and then contribute to the understanding of the effect of the aerosol and cloud on the climate change. And this just gives our mission timelines. So we have a series of missions which can contribute to climate change monitoring. So conclusion, JAXA is contributing monitoring primary climate change parameters, including precipitations, water cycle, greenhouse gas, and cloud and aerosols. And but after GCON-C1, the JAXA climate change mission are not certain. Continuity of mission and also data is the most important for climate change research and applications. And we consider the calibration and validation on the data is also very important. And international cooperation and coordination in mission development and operations will be most important and necessary for the future climate change missions. Thank you very much for your attention.
We have a few minutes for questions or comments that you wish to pose to the speaker.
Well, Mr. Yoshida, I have a question about the carbon dioxide concentration slide that you were showing. It's not very clear to me. The slide said that these are simulated concentration. And does that mean they do not include any measurements from Carbosat, or do they include measurements for Carbosat and they display what the model says?
Yes, primary data set is, of course, the observation data from the GOSAT satellite. But GOSAT data is affected by many clouds. And then, so the data is very sporadic. So we had to fill the gap by in-situ measurement and also assimilation data.
Any further comments? May I ask that if the greenhouse gases observing satellites, the progress that has been made in measuring the emissions at the surface, would you say that in the future that can be helpful to monitor the emissions of different countries so that we can, in fact, monitor that in comparison with their inventories of emissions?
Yes. Actually, the GOSAT is a joint project between the JAXA and then Ministry of Environment and also National Institute of Environment Studies. And then purpose of the mission is to contribute to UNFCCC, IPCC, and then SBSTA. and then decrease the uncertainty of the CO2 estimations. And then we are now developing a GOSA 2, which has a higher resolutions and higher accuracy. And then our Ministry of the Environment goal is to make maybe a GOSA 3, which can make a good estimation over country-by-country emissions.
Well, if there are no further questions, oh, sorry, please.
The data collection, or better, the coverage of these satellites is mainly for the northern hemisphere or is global?
Yes, they are global, yes.
Last question.
Yes, excellent presentation, and I fully agree with you that satellite observations also need a ground-based observation support for calibration and validation. So in this regard, from the WMO perspective, we are more than happy to support in these active areas, including inter-collaboration between the satellites, and especially for the climate change. Thank you.
Yeah, thank you very much. I totally agree with you.
Thank you very much. So now we've moved to Dr. Christian Eggenhofer.
Good morning, everybody. You might wonder what I'm doing in this conference, because I'm not probably one of the few, if not the only, non-specialist on climate or on space observation. So maybe I'm a bit the odd man out, but let me explain why this makes sense. I think the invitation is partly owed to the fact that in 2011, with my colleague, we did a paper on space observation systems and underused assets in EU and global climate change policies, where we looked at the interface between space, which for us was a very new and difficult area, and how the EU operates within this, which I don't explain, I don't have to tell you a secret, was a very strange and animal, the EU, for the space people in the European side as well. So we put this together and said, how could this all go together? So typically, we are not working on space, we are working on issues like power market design, how you design an ETS, emissions trading system, and so on and so on. But what I would like to do today is to give a bit the policy context in which all this, as I understand, very fascinating and very important work of the space observation industry or agencies is undertaken. Now, please keep in mind we are very EU-centric. We are an EU institute, so we always look from the EU side, and so that I think is important to be kept in mind. Just very briefly to give still a little bit more background, we are a Brussels-based think tank dating from '83, and we deal with all policies, agriculture, trade, macroeconomic, whatever have you. And we are about 60 researchers, so we are very small if compared to all the other organizations present here. I'm heading a team of 13 researchers dealing with energy and climate change. And what we usually do is we work on policy reform and say, hey, here is something which doesn't work, it should be changed, improved, and then we work with the stakeholders. That could also be space agencies, that could something else, to actually get this policy through, because unless you make the case in some areas with the policy system, it's very difficult to actually get the things done. So, what I thought today is to give a little bit of background also what this climate change means. I mean, it has been presented in the first part, but I would like to give it a little bit more, a little bit more tangible perhaps, and to give you just the idea here about this trajectory. very often in debates which are not climate change specialists, people are not fully appreciating the kind of challenge. This is not just of, we're doing a little bit emission reduction and the problem is solved, that this is a very, very serious challenge. This, we need to, in order to get somewhere close to the 2 degrees target, political target temperature increase, to reduce the CO2 or the greenhouse gas emissions about half in 2100 or probably even more. I put up a very moderate, modest reduction trajectory. If you really go for the 2 degrees, probably would be much, much more. So just to think this is a long-term, very important issue. You all know this, but it's not everywhere always appreciated in the discussions. Now, we also tried to put these figures, you all work on numerical, all work on numbers, we tried to put this into more tangible parts. Now, these are 2008 figures, whatever we have calculated them. Please don't hold me responsible for all of these. These are, by and large, a rule of thumb figures, what this reduction would mean. You have here, we talk about, we talk about 6 to 7 billion tons of carbon, not CO2, of carbon reductions. And what we have put here down together is we need 6 or 7 of those to achieve these reductions. So, you just look at, we would need to change, for example, option 5, change all the cars we have in this world currently from petrol or diesel driven or fossil fuel driven into hydrogen. Now you say you have to do a lot of more nuclear, a lot of wind and so on and so on. I leave that with you. So just give you an idea, this is not small matter. And I think also within the world of the space agencies, where we have found out, yes, everybody knows climate change is important, but maybe the scale of the objective is not maybe always understood or at least sort of communicated. So let us, that I think was already mentioned before. You put this in your presentation from some reports, some messages from the fifth assessment report. I don't want to get them into this. The presentation is probably going to be available, but it's clear climate change, warming is unequivocal, and there are observed changes and so on and so on. And that is also, I understand, part because of the agencies. Now, last point before I get into more of the discussions in the linkage between the agencies and the space observation system is we're living now in a very different world than we did before Copenhagen. In Copenhagen, the idea was that there are national or at the EU level commitments which are numerical, and then you have a relative easy to measure, relative easy to verify what is happening. Now, beyond that, we are now not moving from a globally agreed commitments, but to domestic, non-binding pledges. So the Kyoto world is dead, the Kyoto Protocol world is dead, not the Kyoto, be careful with my Japanese colleague here, the Kyoto Protocol world, and we're moving into the post-Copenhagen agreement world, which means domestic non-binding pledges, and they could mean anything. You're planting trees, you avoid deforestation, you have more renewable wind, and so on and so on. So much more difficult to actually assess what is happening. And why does this matter? It matters politically, and here now I come to the more political issues. It matters politically because of verification. Countries say, we're doing this and this, and then the other said, hey, show us the proof. Are you really doing it? What is it worthwhile? So we have these acronymous discussions in the United Nations Framework Convention negotiations where people say, yeah, you're doing this, but what does it mean? So how can the different measures that are put forward by the different countries, parties, be comparable? Because, and here's the third point, in the end, political discussions, the competitiveness matters. Now, competitiveness of industry, you know, steel, cement, and all these kind of things, which is a relatively small part of the overall picture, but politically one of the most important. Therefore, verification, comparability, competitiveness are important issues to unlock, to move further here. And now you're seeing already that we are getting closer to the space agency's issues. So, the space observation issues, underused assets, that's what we had asked in our paper. Maybe they are not. You know, I would just like to put the question, I'm not a specialist on it, but I think it is an important issue in this audience, and I also think it's an important question when you look at funding priorities and this kind of things. And, you know, when you look at the climate change system at the EU, the political system, space observation is, yeah, you know, yes, it's there, it is probably important, but what do we really do with it? That is a little bit the discussions, and this is the discussions which we wanted to link a bit. Whether we have managed or not, I'm leave that to others to agree. So, what do we have in terms of space-based observation? It was mentioned already. There are the satellites, the remote sensing technologies, satellite-based, are now an integral part of the UN FCCC, and they're not contentious. That of course, does not mean that everybody is sort of opening the purse and say we need to do more, but they're not contentious, and they are important to implement efficient mitigation and adaptation policy because we need data, and I will come to this a little bit later. We have now the Global Climate Observing System, the GCOS, which is integral of the UN FCCC, and that is, of course, the key element. The majority of the 44, you know, at least at the times we did, essential climate variables which have been mentioned, that have been identified by the GCOS implementation plan, which is the most important element there, can be obtained by or with significant input by space-based observation. And my previous colleague, or in the first presentation, there was categories, you know, atmospheric, oceanic, terrestrial, the three, it could be used. Now, I think that's the ESA tells us they would be able to get 31 of the 43 through space-based, and I guess that would be the same for most of the other agencies as well, but please, I'm not a specialist on this. So, we all know what the GCOS is. I don't need to mention it, just that the 2004 implementation plan is really sort of the key element which puts this together. Now, why do we need this climate monitoring, prediction and research? That's really the area where space observation can make a difference. Monitoring, prediction and research for mitigation adaptation. Certainly monitoring, there was a lot on monitoring said already, you measure rate of change, variables and so on and so on. But prediction is also important for the future of climate, especially decades ahead. We're talking about a big challenge, which, you know, the costs come now, the benefits later. So here there is a lot to, you know, to communicate that this is a sort of an intergenerational issue. Therefore, you need to have solid, I believe, one needs to have solid data, solid models in order to actually make a solid case what is going to happen. And then, of course, for the research, it is important to collect, and I think collection of data is relatively far ahead, archiving, but also processing of data. That is at least what we have figured out is probably the weakest part in the overall chain. But again, you know, there are more knowledgeable people than we are. So, what does it mean for the policy formation? For the policy, it's first the policy definition. I think this is important also for the public debate. the accuracy, it adds on new accuracy on pace and change of uncertainty, because whenever you have political discussions, people say, yeah, there's a lot of uncertainties, are we really sure? So you get into this kind of debate. The management and scenario building closely linked to this, but I think here the contribution of the space-based observations would be on funding allocations, priorities, but also on post-project auditing. But priorities, I think, is very important. We could get sort of more evidence-based, as we call it, input for the scenario building and all the management. Reporting requirements are very, very important for the international negotiations. The jargon is MRV, monitoring, reporting, verification. I mentioned this. Unless it's verifiable, reportable, and monitorable, it doesn't happen, because you get no credit. A country does something, and if it's not reported, monitored or verified, it's not credited. So that why have countries don't have an incentive to do something? And here we talk about verification of countries' emissions. So the mitigation element, you know, most of it will be on the adaptation, but I think we should not underestimate or forget about the mitigation. Carbon sinks, biodiversity, and you know, there is probably more, but these are the core ones. And then the alarm functions. Forest fires, we are very well aware in Europe about forest fires, which is a major issue, floods, droughts, and then all these implications for food security, access to water, and so on. So the alarm functions, but from a political perspective, I would think the management and scenario building and the reporting requirements function are the most important. And then, of course, the policy definition, although I guess in Europe we have already made some progress on this. Now, I leave this, I finish here, maybe just with the last quote from President Obama as well, which we put on our publication, and which basically means there's a lot of information available, we just need to know. Now, with the NSA situation, you know, maybe there is a little bit of a different reading on this, but I leave this to you. We know a lot, and I think the agencies and the space observation systems can do a lot. It's now need to bring, in my view, that's also a bit my professional deformation, to bring the different constituencies together, but that is true, of course, for all of climate change policy. So thank you very much for your attention, and thank you, Chairman.
Thank you very much for your presentation and for all the challenges that we are facing and the contribution that space systems and observation can give us in terms of climate change. Questions? So open the floor for questions and comments.
Okay, I apologize to take the floor so often, but I have a question for you. It's a bit of an EU-centered question. We have a new European Parliament. We will have a new European Commission by the end of this year, hopefully. Do you see, do you have a clear idea how we could improve the understanding of this climate issue at the higher level of the EU system, and improve also their understanding of what space observation can bring and can contribute to monitor the evolution of climate?
Yeah, thank you for this question. On the first one, I think it's more. I think we know enough. We know enough, and if there is people denying climate change, there is little you can do. I think what would be important now is, from our perspective, to have a more public debate where we are not told by the scientists, policymakers, this is a big problem, there's a challenge, bear with us, to have an engaged discussion which probably has to take place in the society. Now, of course, we are not placed very well to do this. We are a research institute, we're working with policymakers. But I don't think there is a need now to engage with the policymakers themselves. The information is available, accessible, and if people have different choices, I think it's a political choice. Now, the space, how the Space Observations Agency or the Space Agency can interact better, I think you would, that is our standard approach to this, to engage in all the kind of discussions that take place, that you would always add up somewhere the space agency part. You know, if you do special meetings, you get a number of scientists, you know, MEPs, member of parliament, or some other specialists who talk to you, but they already know. You know, how do you get the broader message? The important into this is to be in the mainstream discussions. Now, I understand from the work we have been doing, this is very, very difficult because you really talk very specialist people with their jargon talk to other specialist people with their jargon. So it probably needs to create some sort of constituency, you know, which takes this further, which keeps going, which also does the transmitter. Now, this is maybe a little bit general comment, but this that's the best probably I would come to my mind.
Any other comment, please?
Yes, I'm quite interested in the first question discussion. I could quite agree with you that we may have enough or probably sufficient for see the global climate change, but the impact of the climate change to the different social, natural, and economic sectors are still not clear. For example, if the super typhoon, the intensity of the typhoon and tropical cyclones, or what about the water cycle? And is it really connected to the climate change, or what is the real connection with this are still not clear. So even from policy perspective, I believe that we need to encourage more space missions to really to understand what the impact of the past change and the potential future change of climate to the different natural and economic sectors. One more for your information, for the climate ECVs, now altogether GCOS identified 50 ECVs, and since 2010. Thank you.
Thank you very much.
I mean, I can only speak for the EU and what we know in terms of for Europe, because the borders don't matter here. What we know, of course, is that the impacts, the major impacts, only come in 2040 or beyond. So therefore, to linking the extreme events to climate change is a little bit delicate, and politicians try, but usually they get caught. But this is, again, we have had in Europe very little discussion on impacts, actually. It is that kind of anecdotal level you're mentioning, you know, yes, you link Katrina to climate change or a super typhoon and say, here, we have the proof. I think it is a little bit more sophisticated. I'm not a scientist, so I shouldn't be speaking up, but what I hear from my colleagues in these areas, there is a lot to be discussed, and maybe this is also some of the areas where space agencies could sort of get into this, because I understand they have a lot of authority, and they are also listened to by policymakers. And maybe this is one of the areas where you also get into more interaction with the broader public, or at least with the opinion, as we call them, shapers, yeah.
Well, if there are no more questions, I would just like to mention that the question of very strong tropical cyclones is a very crucial one. I mean, there are some regions in the world that are particularly affected by that. I just mentioned the Philippines, And it's still, there is a lot of uncertainty, at least in published papers, about the connection between the higher percentage of these very strong tropical cyclones and climate change. So this is a field where Earth observation will be very valuable. So if there are no more questions. And we move to the next speaker, Dr. Mark Müller. He's project manager at Airbus DS Geointelligence. This is former Astrium enterprise. He is also the coordinator of INCREO, that's Increasing Resilience Through Earth Observation, project coordinator, and this belongs to the Copernicus project. By training, he is a geographer specialized in remote sensing and geoinformation systems and service and products development in support of disaster management. Thank you.
Okay, thank you, Professor Santos, for this introduction, dear panel colleagues. Dear ladies and gentlemen of the audience, so before I start with this, let's say, a bit more technical presentation, I would like to say thank you first for having the opportunity at all for presenting this project towards you. So it was mainly based on the initiative of UNESCO, the Venice office. So as we are here in UNESCO headquarters, I would like to mention this first, which is in addition also represented in personam by Dr. Mario Scarlett, who will have a presentation later on as well. Okay, so about the content of this presentation, so I will follow this overview, let's say. It's about facts and abstracts, so what is the background and objective and scope of this project? How is the consortium consisted of? Who is involved? Which users do we address? What is the project rationale? What do the project users in the end receive? So what is the project delivering? What data do we use? What methodologies are applied? I'll also intend to show you some product examples we have already now. And also then I will conclude with a summary. I should have mentioned, so in CREO again, that's about increasing resilience through Earth observation, and as I picked up the word before by my former speaker, Christian, so about, let's say, maybe space-based observations is a bit an underused asset, so maybe we can do a little bit to counterfight this a bit. So about the facts, so this is one of the Copernicus projects. Most of you know that this was formerly called GMES, Global Monitoring for Environment and Security. So it is still an FP7 project, so we are performing R&D work within this project. The coordinating entity of this project is the Geointelligence Program Division of Airbus DS, the legal entity Sportimage, and altogether we are a consortium of 10 partners. We are covering a broad range from industry, science, institutions, and universities as well. The project duration is about 2 years. We started early last year and we will finish end of this year. And the total cost you've seen is written below, so it's about 3 million euro roughly, with a EU funding of roughly 2 million euro. So what it is about, so clearly we address actors responsible for disaster management, civil protection, risk prevention, and spatial planning. So this is our target group. And the main idea of this project is that we rely on Earth observation data as the key means for developing our services and products in the framework of this project. And it is mainly dedicated to supporting preparedness and mitigation measures for areas which are already vulnerable to natural disasters, and some areas also with already noticeable climate change trends. So about the background of this project, so how did it come at all that we received the funding for this and that we can perform our work? So we need to go back 2 years to the EC's work program for 2012, where it was written space-based applications at the service of European society are one of the activities to be funded within this framework. So, and here INCREO particularly addressed the support to emergency response management, so as one of the components to the formerly mentioned GMES space domain. A bit more about the background and the related objectives. So some of you know that, let's say, in recent years, the response phase, the critical phase of, let's say, disaster management received some funding already. But here within INCREO, we are clearly addressing the non-response phase, which means if you consider the risk management cycle where we have prevention, preparedness, the actual crisis and post-crisis. So we are addressing and supporting solutions before and after the critical and the crisis situation. So altogether, this is meant to support risk and vulnerability mapping, including tools and products. This could also be some web or online platforms for enhancing strategies related to preparedness and mitigation. Some of the key words of this project, so it's about resilience. So you can see here an explanation, so what it is about. So we intend to strengthen societies and the environment's capacity to respond better or more adapted to occurring natural disasters. So that's one important, let's say, key factor of this project. Then it's not only about single selected disasters, only flood, only landslide, and so on. So for some use cases, we particularly address the multi-risk situation where we have, for example, flood and landslides, also earthquakes triggering landslides, and so on. So that's another important factor. And then we also intend to more address what we call assets mapping. Assets is here understood as the monetary values per area unit. For example, in this case, we intend to map areas and buildings, for example, and rendered by a unit in euro per square meter. And this we are currently doing at different levels. So we address not only the national level, but also the regional level and the local level. Depending on the data source, we are able to do so, what I will show you later on. I have mentioned already the consortium, so let's say we can categorize this consortium as follows. We have on one side clearly the service providers, the ones being responsible for developing the services and the products, mainly on the use of the Earth observation data. You can see a list here representing companies from different countries across Europe. So it's industry, but also national institutes, for example, of meteorology and hydrology in Bulgaria. We have a National Research Council involved from Italy. We have a German industry, Geomer, but also from Austria and institutions from France, like Météo France. Then the whole work is, let's say, supervised by ITC, Faculty of Geoinformation Science and Earth Observation in the Netherlands. So they are some sort of, yes, they are on one hand side involved themselves, but also supervising the technical work of the overall project. For some work packages, this is also done by the support of ECMWF, as we have also work addressing storm wave, wind surges, and so on. So here we have ECMWF involved. And then additionally, we have a research foundation involved supporting our work in Italy and Albania. So the users, these are the ones we are developing our work for. You can see that this is, again, a broad range of institutions involved, again, from different countries across Europe. So we have some, let's say, focus on work in Italy, where we have the civil protection involved, but also stakeholders from the regional municipalities and so on. We have several Ministry of Interiors involved, for example, in Albania. So this is a broad range where we support their work with the objective in the end that our solutions will be implemented by them for their daily routine work. So, and then I put this in red here, so that's quite an important role. It's about the interfaces. So sometimes, you know, it might be required that, let's say, what has been technically done needs to be translated somehow for a better understanding on the user side. And likewise, in the other direction, we need some interpreters for technically better understanding what is needed on the user side. So that's why we have, specifically in Italy and in Romania, the UNESCO involved, and in Romania, it's the Romanian Space Agency, helping us in better understanding the end users' needs and requirements. So that's an overall view of the project's rationale. So in the work packages on the left-hand side, we deal with what we call as assets mapping. So I explained this earlier. So the idea is to develop this on different scales, national, regional, local, and also for being able to transfer this to other regions worldwide. So not remaining EU-centric, as it was mentioned before, so but having something at hand which can be transferred to other regions as well. And also for this, we need to take into account current available policies, frameworks, and so on, which are, of course, to be considered when technically developing such solutions. Then in the middle of this graph, you see several boxes as well. So yes, we have some single use cases with one natural disaster at one site, but also we have this multi-risk test site, which is indicated in green here, where we address several natural hazards. And then, of course, so we also address, let's say, concepts or try to implement concepts which are suitable to be implemented on the global level. So, for example, global solutions dealing with sea level rise and climate change as well. I will show this later, so that we do not remain only EU-centric, but also take other areas into consideration. So now the question is, what do the users receive in the end, what it is about? So it's mainly about risk and vulnerability mapping. Some prefer this still as analogous maps, some others say digitally only, but it's also about, let's say, development of tools where users can access the area of interest and where they can select what is needed in terms of data layers. Is it only the satellite image? Is it only the land use? Is it about the critical infrastructure? So this is all what we address, and you see the list of the more specifically solutions. It's about the assets maps. If you have them at hand in combination with disaster extent information and the knowledge about damage functions, you are also able to perform a damage assessment, which is quite of use for future events to come and so on. And again, not sticking to the local or regional level, we also have the global concepts in mind. So that's maybe not such a sophisticated graph, but the intention here is just to say we address different levels in terms of assets mapping. So let's say when we start from the bottom where we have this basic European assets map, we show you examples later on. This is what is available on country level, but when you go further to the top, so the level of accuracy is increasing, but the degree of transferability to other regions is decreasing. So that's the trade-off we have to make, but quite often we are, let's say, steered by the users indicating us what he is requiring. So this is one of the product examples. So this has been done already in the predecessor project of INCREO. So it's an assets map, again, this basic European assets map. And you see this for two countries. So that's in the north, Romania, in the south, it's Bulgaria. Unfortunately, we cannot clearly see the border or the Danube River. So this is meant to be of use for flood events and for better assessing damages as a consequence of such events. And as you know, this is they do not stop. No disaster does stop at any border, and also for, let's say, for mitigation and for better dealing with it, it is more of use to have homogeneous data sets available across the border. So this is something what is given by this BEAM product, and just to better understand, it shows the euro per square kilometer for the urban areas in these two countries. So, as said before, if you have such a data set at hand and you combine it with information about a flood extent, so as it was done here, or as it was available here for the Skotra area in Albania, and if you then apply later on damage functions, where you, of course, I mean, you need some specific knowledge for applying them to these regions, then this enables you to perform a damage assessment and for being better able to indicate the amount of money affected, and of course we should not forget the population. So, but this is a part of this product anyway. So, okay, the remaining time is causing some problem for me. So let's speed up a bit. I mean, I mentioned the other levels, so this is now more focusing on the regional levels. This is where we use, let's say, or rely on more up-to-date Earth observation data, more accuracy, for example, for the high-RAM and the AM Plus products, we rely on Pleiad data ranging from, let's say, 50 centimeter, but also we can use other optical data, spot data with 1.5 meter. So this is one of the essential data sources for these developments, for being able to have assets maps at another level. So, for example, we speak of scales here being larger than 1 to 15,000, so then you can imagine that this is more for use on the local level or in the field. So how do we get now to these final products? Let's say it's an intersection of different GIS layers. So as we did here for the city of Dresden in Germany, so we combined this information with, again, available flood extent information, allowing for estimating the damages in this area. So this refers to a flood event in June of last year. So it gives an idea about the assets value per inhabited building. So that's where we focused on. So, and we were able here to select the buildings affected and also the related monetary value. Of course, in relation to the area flooded, so because that's where we are focusing on. We did something similarly for the Alpago region in the Veneto of Italy. So same product. In addition, we have information available about landslide vulnerable areas here. So that again, with this stack of geo information, we are able to better assess where are potentially future events and related damages. That's now more about the details, so it's not only about the building assets, it's also about the population potentially affected. So we perform here, in addition to the other products, also something like which is called a routing analysis, so which is enabling the civil protection in the end to better finding better ways for evacuate the people in these affected areas. So you can imagine if there are landslides, they are blocking streets, so it will require a detour. So this is taken into account, and if you specify one point which is not passable anymore, then it will be automatically a detour derived. So we have other use cases where we address the coastal areas in France and in Bulgaria. About the methodology, so I mean the keywords are mentioned here. It's about downscaling. So the idea is to obtain more detailed data as a means for better predicting future events. So that's the idea here. In the use cases, it is referred to the Xynthia storm, which is well aware, I guess, to most of you. So it enables us to provide a contribution for improving future forecasting models. Comparable analysis was done for Bulgaria and the Black Sea, where it was possible to determine the wave heights and so on, also in future supporting mitigation measures and so on. So then I come to speak about earthquake risk maps. So that's done via, let's say, some simplified modeling approaches, indicating areas hit by the earthquake. And also, again, we address the assets values affected here, and also, let's say, the population endangered, and for better enabling their evacuation. Landslide susceptibility map. So this is another product. So with the information available, we were able to better locate the areas. Of course, we have a lot of local knowledge in becoming part of these analysis, but in addition we have terrain data, and we have information about affected areas from the past. So this is all becoming part of this approach. And getting back more again to the, let's say, Earth observation-based solutions, here this is an example for a time series based on TerraSAT satellite imagery. So this is one means for detecting vertical measurements over a longer period of time. Last but not least, this is another application. So here it's what I called earlier as the global risk and vulnerability. So a global concept, and as you can imagine, for this we need data sets enabling us to do so at all, or let's say in the first place. You know about these data sets. There is a new data set available now. So with homogeneous quality across the world, so that's something new. This is something where the project is benefiting from, enabling us and the partners for more accurate analysis in terms of sea level rise, flooding, and so on. I will show this in more detail when we have a look here at Toulon in the southeast of France, where you can see, if you compare the World Dam product on the left-hand side versus the Aster global dam on the right-hand side, that some areas are just not recognizable in the Aster Dam, and this of course is a big problem in case you apply sea level rise scenarios, which means that for some scenarios not a single place is yet flooded using, let's say, less accurate data. So this is a big leap forward for better indicating potentially endangered areas. So that's quite essential. So for concluding, this project is about providing geoinformation products in support of prevention and preparedness measures. So monitoring is a key word as well. So the users involved, I mentioned already, the real actors being responsible for disaster management mainly. Then the solutions are based on the use of EO data in combination with GIS data, plus modeling whenever possible. And then the project is putting emphasis on multi-hazard and multi-risk. And so for doing something, for improving the resilience and for better protecting population and environment. So thanks for listening.
Questions or comments on this paper? Well, I have a short question. In making these risk and vulnerability maps, do you take into account projections of climate change, for instance, for floods? This is something which in the future will be probably will change. And,
Yes, we absolutely do, and maybe this wasn't mentioned sufficiently. So there was only at the end the example for the city of Toulon in this area. So I mean, this is taken into account, not for, let's say, all of the work packages, but for some of them. And the idea, as it is quite often in such R&D project, is that at least we intend to develop the concept, which can then be applied to other areas. For example, the plan is to do so, like for Toulon, for coastal areas in Indonesia. So this is taken into account, as well as regards landslides, where we know about areas where we have increased rain amount and increased rain events, so that we can take this into account in terms of more landslides to come.
Well, I think if there are no more questions, thank you to the speaker. And we move to the last speaker. It is Dr. Mario Scalet. He's head of science at the UNESCO Regional Office for Science and Culture in Europe, based in Venice. And his background is in plant physiology, professor at University of Udine in Italy, and Department of Applied Biology, and has published about 50 research papers. And since 1993, he's dealing mainly with programs of international cooperation in science and technology.
Thanks for the presentation. As you heard, I am not a specialist in satellites, but I am a specialist more in potatoes, something like this. But I have quite relevant experience in international cooperation. And FLADIS is one project that is in some way a sort of twins project with INCREO. INCREO, we can say that is a project who is more static in some way, because the final deliverable is maps. FLADIS instead is a project that is more dynamic, because the final deliverable is a system. The project, the title is quite self-explaining, is integrating the GMS initial operation, emergency management service, and the global navigation satellite system for an enhanced flood information service. This project is an European project, FP7, and is a project to provide a flood information service that aims at better addressing and mitigating crisis situations arising before, during, and after heavy flooding. The flood solution aims to close a critical gap for disaster management teams and emergency responses unit by retrieving location-based information from users. Third point is to provide filtered information to the public together with flood delineation maps produced from inundation models that run on the geospatial and weather information at hand. The EC-funded FLOODIS project will utilize the service like GIOMS, GMS Copernicus European Emergency Service, and the European Flood Awareness Service to provide advanced service to mobile users. As you can see, this project, one of the most important issues is to to work together with all the stakeholders in the line of emergency response to the disaster, natural disaster management. The project is implemented by a consortium formed by this institution, the Istituto Mario Boella, Italian institution based in Turin, Geoville from Austria, UNESCO, Alpha Consultant, ND Consultant, Terranea, and Explore. The goals of the project is to reduce the social impact of floods events, create an early warning system, combine space-based asset with ground-based information to create advanced service, to support a civil protection agency operation on field through an enhanced flood modeling, create a platform to integrate commonly used devices and social tools. The process, how is the process of this project? When a flooding event is triggered, is to enhance data collection and integration from in-situ sensors that are located at water level in the rivers, civil protection agencies, professional, and civil user contribution. More precise flood modeling through the integration of the Earth observation and the advanced positioning technologies. During the flooding event, the elaboration of the enhanced map to support the on-field operation through a continuous update of the flood model. Alert and messaging system both for professional and civil users through FLOODIS application. After the flooding events, data post-processing and integration in the flood modeling platform. This is an overview of the system. An important issue is the collection of data from the social network and from the water sensors, and then the system of professional devices. All these data are then coordinated and elaborated by the control center and the system. From the space, we have data collecting data from the space assets. The project is organized in work package, as you know, and started in October and will terminate in June 2015. I think it's better to go ahead. What is the expected impact? Is to collect a large amount of information through mobile sensing, the water level detectors, and the human sensor that are the stakeholder convened in user committees to provide a better delineation of the flood events. increase the precision and the impact of flood alerting and monitoring system through the combined use of space asset, Earth observation, land mapping, and so on, and the GNS technology. Improve the ground operation of emergency response units through a better positioning of on-file resources. Support the citizens in flood-related emergency situation with dedicated mobile application. Which are the selected sites for this, for the development of the system and the application of the system? Are two special areas where, especially during the last years, the flooding events are relevant. One is the Lake of Scutari in Albania, that is the largest lake in the Balkans, and is a relevant area from an environmental point of view, since it's a Ramsar site. You know, Ramsar is a convention that protect areas where there is a relevant aspect of biology of birds. In that area, there are also 3 relevant, important hydroelectric powered dikes. There is a relevant agriculture around the lake, and this is one of the most affected areas by heavy rainfall and water level rise. One of the last important, 3 minutes, okay, I will. More than 12,000 people were evacuated in 2010. The second area is Bacchiglione River. That is a river that passes across to important city in Veneto. The 2 cities, Vicenza and Padua, that are also contain a World Heritage Site of UNESCO, acknowledged by UNESCO. And these rivers arrived very close to the Lagoon of Venice. So there is a sort of influence to the lagoons of Venice. And as, okay, Skodra is some picture, and Veneto, this is the map of Bacchiglione River that crossed the 2 cities and arrived at the southern part of the Lagoon of Venice. So why UNESCO is involved in this project? Because UNESCO is strongly engaged in the action, international action against, in order to mitigate the effect of natural disaster and to enhance the preparation to natural disaster. For this reason, UNESCO is the activity, this kind of activity is one of the main line of action of UNESCO in the field of science. Our office, that is located in Venice, take care of, as mandate, the Balkan areas, and for this reason we are working with Albania and also with the Lagoon of Venice, that is a World Heritage Site of UNESCO. A key aspect of this project are the user committee. We established this user committee. Our role is to try to establish and coordinate the action of this user committee where all the stakeholders are in. So the different aspect of all the system for disaster management, it means scientists, policymaker, civil protection agency, and local authority are in this user committee, and together try to elaborate, give recommendation, give element to the project partner in order to develop this system. So, the main objective, and this is the last slide, is to develop this is a professional location, to develop a professional location based on mainstream-oriented disaster alert and information system for flood events. to act as a demonstrator and precursor service for maximizing accessibility of environmental and security-related information through location-based dissemination via smartphones and other handheld devices. This is the main. I will stop here. So I am.
We have time, thank you very much. We have time for just one question or comment. Well, please.
Okay, so these last two projects, in fact, are FP7 projects as part of Copernicus. And they will end, one of them will end at the end of this year and the other one in the middle of next year. And the real question that I have is what next? You have already made proposal under Horizon 2020 for follow-on activities, because these are typically one-shot type of projects, and I'm worried that nothing will come out of it if there is not some kind of building up on the longer term on these activities. So any of you two, Mr. Scarlett or Müller, can answer my question.
I can answer from UNESCO perspective. UNESCO is not a normal partner. We have a mandate, so our role is not limited to one-shot project. Is one program that try to change something. So I didn't present other aspect of this project, but both projects in some way are not one-shot. There were before other projects within European Union and not as a European project, but other activity were done on this issue. And one of activity of this end user committee will be to try to link this project to the previous activity done. Because this is another important aspect of international cooperation. Try to coordinate the action of the numerous international agencies that work on the same issue and try to profit of results already achieved. Because, for example, there are some systems that is implemented in Albania, where there was a strong international cooperation, for example, from Italy. Then there is one system that is already implemented. So our challenge is how the results of this project could be linked to this system that is ongoing, and how this system can profit from this project. So for the future, then, we will see at the end of the project, and we will try we will have a final conference. In this final conference, we would like to invite stakeholders, including the European Commission, in order to give some elements to go ahead. I don't know if you want to add something.
Yes, maybe from the INCREO point of view, I would like just to add a few comments on this. So let's say we are aware of such concerns, but let's say an answer on this should be twofold. So within the current INCREO project, the consortium has one common interest, which is first this project, and to develop something which is sustainable beyond, so which would, let's say, mitigate your concern, as the objective is to provide and to develop and provide something which can be used on the user side in their daily routine anyway, independent of the project and the original project frame. So let's say, but besides this consortium interest, every partner has his own interest, let's say, beyond the project frame. And let's say from our side, at least over last years, there was something like a continuous development in this domain of services and products, so that it is either for new projects, maybe Horizon 2020, some of the partners expressed interest in this. It could also be for upcoming other tenders. So you know about the emergency management service from Copernicus. This is to be renewed very soon. And then, of course, as a last option, there's always this internal service development for continuation of activities. So.
Well, thank you very much for the speakers and for the questions and comments and for your presence, and the session is closed. Thank you.